This star should not be here, and its chemical fingerprint hints at something even stranger. S0-6 may have been born outside the Milky Way, then drifted into our galaxy before skimming the most dangerous place in it. Oh, not near a black hole, not somewhere in the halo, right next to Sagittarius A star, the 4 million solar mass black hole at the center of the Milky Way. Right there. And that changes the story, because this is no longer just a tale about a monster in space. It is a forensic investigation written in starlight. One star, one orbit, a handful of elements in its atmosphere, and maybe, hidden in those atoms, the record of an intergalactic journey. What is S0-6? It is one of the fast-moving stars packed around Sagittarius A star, part of the so-called S stars that race through the galactic center under extreme gravity. How do we know it is unusual? Because when astronomers measured its chemistry, they found a pattern that looks out of place for stars born in the Milky Way's central regions. Why does that matter now? Because modern infrared spectroscopy and decades of orbit tracking are finally letting us connect motion with origin. And the payoff is huge. This star may be carrying a message about how galaxies grow by stealing from each other. To understand why S0-6 is such a problem, start with where it lives. The galactic center is violent. Gas clouds collide. Radiation is intense. Gravity is brutal. Near Sagittarius A star can move at thousands of kilometers per second. Some pass so close that their orbits become tests of Einstein's general relativity. In 2018, observations of the star S2 during its close approach helped confirm gravitational redshift near the black hole, with teams using instruments at the European Southern Observatory's Very Large Telescope. That alone tells you what kind of neighborhood this is. It is not a gentle nursery. It is a cosmic knife edge. So the obvious assumption is simple. Stars near Sagittarius A star probably formed from material in the Milky Way, or were somehow rearranged there by the black hole's gravity. That sounds reasonable.
Personally, I used to think that explanation would cover almost everything in the galactic center. Dense region, extreme environment, local solution. Done.
But S0-6 refused to cooperate. In 2020, a team led by astronomers, including Jessica Liu at the University of California, Berkeley, reported detailed chemical measurements for S0-6. Using Keck Observatory data from Hawaii, they analyzed the star's spectrum, the barcode of light that reveals which elements are present in its atmosphere. And the pattern looked more like stars from dwarf galaxies and the Milky Way halo than stars expected to form in the galactic center itself. That is the clue at the heart of the mystery. Chemistry is hard to fake. A star can be pushed, scattered, or captured by gravity, but its elemental abundances often preserve where its gas came from. Atoms remember. Think about it on a human scale. If I meet someone in New York with an accent, a passport, and recipes passed down for generations, I can often tell their family story did not begin in Manhattan. S0-6 may be doing the same thing. Its orbit says, I live here now. Its chemistry may be saying, I did not start here. And this is where the angle becomes fascinating. We usually imagine galaxies as clean islands of stars. They are not. They are messy, hungry systems. Over billions of years, the Milky Way has cannibalized smaller galaxies. Streams of stolen stars still wrap around it like shredded evidence.
The Gaia mission has helped reveal many of these merger scars, including the debris of ancient collisions such as Gaia and Enceladus. So could S06 be one of those immigrants? Not just a visitor to the Milky Way, but a survivor that sank all the way into the central parsec? That sounds almost absurd, and yet it may be exactly the point. Before I show you how a star like this could end up beside our black hole, I want your take. Do you think S06 is more likely a local star with weird chemistry, or a true outsider captured from another galaxy? Drop your answer in the comments before the trail gets even stranger. Here is the problem. Getting close to Sagittarius A is hard. Staying there is harder. A star from the outskirts of the Milky Way, or from a swallowed dwarf galaxy, would need a path inward. Not a straight fall, but a long chain of gravitational nudges, interactions, and orbital evolution. This is where the structure of the galaxy matters. Over time, star clusters can spiral inward through dynamical friction. Binary stars can be disrupted. Stellar populations can be reshuffled by tides. In some models, stars born farther out can be delivered toward the center through repeated encounters. Slow process, violent process, but not impossible. One parsec is about 3.26 light years. The central parsec around Sagittarius A star is tiny on a galactic map, but dynamically, it is one of the most extreme environments we can study. That is why S0-6 matters so much. It did not merely survive a rough neighborhood. It may have crossed almost the entire social ladder of the galaxy. And I think that is the deeper insight here. We often treat the center of the Milky Way as the most native part of our galaxy, the inner sanctum. But if S06 really came from outside, then even the heart of the Milky Way contains immigrants. The place that feels most central may also be a museum of cosmic theft. There are real numbers behind this. Sagittarius A star contains about 4 million times the mass of the Sun. The Milky Way itself is thought to have grown through multiple mergers over more than 10 billion years. The Gaia-Enceladus event likely happened around 8 to 11 billion years ago, according to several studies using Gaia data. And S-stars near the center can reach speeds of several thousand kilometers per second near closest approach. Put those facts together, and the picture becomes unsettling. A star can carry the chemistry of one environment and the orbit of another. But there is still a catch. Chemistry gives us a fingerprint, not a signed confession. A strange abundance pattern does not automatically prove an extragalactic origin. It could point to an unusual formation pocket in the Milky Way. It could reflect a stellar population we have undersampled. It could mean our models of the galactic center are still too neat. That uncertainty matters, because astronomy is full of beautiful stories that collapse when one extra measurement shows up. Confess something? That is part of why I love this case. It forces restraint. It rewards evidence over romance. And still, the romantic possibility is hard to ignore. But wait, the biggest twist is not that S06 may be foreign. It is that a foreign star may be one of the best witnesses we have to the Milky Way's hidden crimes. If its chemistry really traces back to a smaller galaxy, then S06 is not just an oddball near a black hole.
It is merger archaeology in real time. A star that wandered into the galactic center and kept the receipt.
That changes everything! Because now the question is no longer, how did this star survive? The question becomes, how many more are there? If one chemically unusual star made it in, maybe the galactic center is not a closed family. Maybe it is a graveyard of captured histories. Can you imagine that? The most dangerous region in our galaxy, doubling as an archive of stolen worlds? This is where new instruments matter. The Keck telescopes, adaptive optics, and long-term monitoring of stellar orbits have made the galactic center far less blurry than it used to be. Future observatories, including the extremely large telescope, should sharpen this picture further. Better spectra mean better elemental abundances. Better abundances mean a better chance of separating local stars from intergalactic immigrants. And honestly, if the idea that one star near Sagittarius A star might be carrying material from another galaxy surprised you as much as it surprised me, leave a like. Just that possibility alone makes the center of the Milky Way feel far stranger than most people realize. There is also a human lesson buried in this. We love categories, local or foreign, born here or arrived later, center or outskirts. The universe keeps smearing those lines. Galaxies merge, black holes stir the evidence, stars migrate, matter gets recycled. Identity, even on a galactic scale, turns out to be less fixed than it looks.
And personally, that makes S0-6 feel almost intimate.
Not because it is close. It is about 26,000 light years away, near the galactic center.
But because its story is about survival, without belonging in the obvious way. Have you ever seen something in the wrong place and realized it was actually a clue? That is S0-6. My own view is that the extragalactic explanation is plausible enough to take very seriously, but not settled enough to declare victory. That is the honest position. The chemistry is compelling. The environment is extreme. The mechanism is difficult, yet not absurd in a galaxy shaped by mergers.
If more stars near Sagittarius A star show similar abundance patterns, this stops being a curiosity and becomes a new chapter in how we understand the Milky Way's core. And that may be the real reason this case matters. Not because one star is weird. The cosmos is full of weird stars. It matters because S06 connects three of astronomy's biggest ideas in one object: black holes, galaxy mergers, and chemical memory. One orbit ties them together. One atmosphere preserves the evidence. One star rewrites the scene. So when you hear the center of the Milky Way, do not picture a sealed vault. Picture a crime scene under infrared light. Picture stars racing around a black hole. Picture one survivor carrying atoms forged in a different neighborhood of the universe. And picture this final possibility. S06 did not just survive the black hole. It survived long enough for us to read its past. If stories like this expand your sense of what the universe really is, messy, violent, and full of hidden ancestry, subscribe and stay with me. Because out there, the strangest objects are not always the ones that explode. Sometimes
They are the ones that quietly remember.